finding slope from points, tables, and graphs. Let's review that slope is a rate of change. It's often referred to as a rise over run, or delta y over delta x, change in y divided by the change in x, or y2 minus y1 divided by x2 minus x1. All three of these are the same thing, but we often use them in particular situations, such as when we have a table, when we have a graph, or when we have 2 points. Let's take a look at our first example. Find the slope of the line that passes through the points 3, 7, and 5, 6. In this example, we are given a coordinate here, as well as a coordinate there. Since 3, 7 is listed first, we'll call that point x1, y1. And since 5, 6 is listed second, we'll denote that as x2, y2. Now, when we go to use our slope formula, we know where to put our values. Every time you calculate the slope between 2 points, you start with this giant subtraction fraction. Now let's go grab our values, y2 and y1, and put them in the right place. Now we need to grab our x values, x2 and x1. And we simply compute 6 minus 7 and 5 minus 3. And now we have the slope, or the rate of change, between those 2 points. Let's try this one more time. Again, we're going to use our y2 minus y1 divided by x2 minus x1 formula, starting with our giant subtraction fraction and grabbing our y values first and our x values second. Now in this case, the x1 value is -2, and our formula has a subtraction sign in it. So that means we're going to have subtract a -2. So be careful when you're writing your values into this formula. You might have minus a negative. Compute this accurately. 4 minus 2 is 2, and 8 minus -2 is the same as 8 plus 2. So 2 over 10 is correct, but it can be reduced to 1/5. Now let's find the slope when given a table. So oftentimes when a table, we could simply just choose any 2 points we want. And we would perform the same subtraction fraction, right? The same slope formula as we did before, with y2 minus y1, right here, divided by x2 minus x1. We could do that. Or we could look for a pattern using the change in y, like this. How does 4 become a -1? Well, we subtract 3. How does -5 get to 0? Well, we add 5. And if we're doing it right, we should get that same constant pattern. How does 1 become -2? We subtract 3. How does 0 become 5? We add 5. -2 to -5, subtract 3. 5 to 10, add 5. Now don't forget, we put the pattern of the y's, or the changing of the y's, in the numerator. And we put the delta x, or the changing of the x, in the denominator. So this table has a rate of change of -3/5. Now let's take a look at the graph. Typically, when we go to find the slope of a graph, we use this phrase here, rise over run. Although we could also write the coordinates down for each point and use the same formula as before. But sometimes it's easier to count along these grid lines by finding the change in the y values or rising up from one point until we reach the other point. So this has a rise of 4. We're going up 4. And then we have a run of +1, +2, +3, +4, +5. Make sure you put your values in the right place. So 4 is the rise and 5 is the run. Now it doesn't matter which point you start with. I could have started with this point and said my rise is going down, or -4, and my run is going left, or -5. And -4 divided by -5 is the same as +4/5, which is what I got before. Let's try this one last time. When given a graph, we calculate the slope by counting the rise and run, and it doesn't matter which point you start with. So I'm going to start with this top point here, and I'm going to rise 1, 2, 3, 4, 5, 6, 7, or -7 is my rise. And now my run is 1, 2, 3, +4. And that's how you find the slope from points, tables, or graphs.